Now let's talk about inverses and how it relates to function composition. When we talked about inverses, we've said in the past that they undo a function. They take whatever our output was and tell us what input got us there. And so if we do a function first and then we do its inverse, we should just get back to where we started. When I say do a function, what I'm really meaning is plugging the inverse into the function or plugging the function into its inverse and seeing what we get. We have a theorem here, and our theorem says that the functions f of x and g of x are inverses if and only if f of g of x equals x and g of f of x also equals x, which is to say that if these two functions are inverses, when we plug our input x into a function, we will get the same output x. And when we plug x into the first function and then plug that into the inverse, we get the same thing back. And this should work for any value of x that we could plug into this, which is to say that f of g of 2 should equal 2, and g of f of negative 1 should equal negative 1, assuming that negative 1 is in the domain of f, that 2 is in the domain of g, and that the output is in the domain of the other function. So, let's look at an example. Are the functions 2x plus 1 and 1 minus 2x inverses? Just from looking at it, it looks like they could be. How can we check? Well, first we'll look at f of g of x, and next we'll look at g of f of x. It's important to note that we can't just plug in a specific value of x and claim that this works. It needs to work for x in general. So with that being said, we're going to plug the function 1 minus 2x into f of x. In two steps, this is f of 1 minus 2x. And then we ask, what does f do? Well, it takes its input, doubles it, and adds 1. So we will take our input, 1 minus 2x, we will double it, and we will add 1. After simplifying, this is 2 minus 4x plus 1, or negative 4x plus 3. Since this is not equal to just x, f and g are not inverses, which means we don't even need to check this one, although we can if you want, and I encourage you to do so. Try it on your own. This time it's asking, are the functions 2x minus 1 and 1/2 x plus 1/2 inverses? Once again, we're going to look at f of g of x and g of f of x. This time g of x is 1/2 x plus 1/2, and we're going to plug that into our function f. That means we'll write f of 1/2 x plus 1/2. We're going to say, what does f do? Well, just like before, it takes its input, doubles it, and subtracts 1. So we'll take our input, 1/2 x plus 1/2, double it, and then subtract 1. Maybe you can see where this is going. This is going to give us 2 times 1/2, which is just 1x plus 1 minus 1, which is x. Great. This is a good start. This makes us think that yes, maybe f of x and g of x are inverses. If we want to be extra sure though, we have to check the other way as well. If you go on to take math reasoning, we'll talk about why. But let's do the same thing. This time we're going to take f of x and plug it into our input for g. That is, we'll write g of 2x minus 1, and we'll ask, what does g do? G takes its input, multiplies it by 1/2, and then adds 1/2. So we'll take the input, 2x minus 1, we'll multiply it by 1/2, and we'll add 1/2. 1/2 times 2 is just 1x, minus 1/2 plus 1/2. Once again, we're left with just x. If we do this, we get f of g of x equals g of f of x equals x. If we plug in an arbitrary input and we get that these two functions undo each other to get just whatever we started with, in this case x, then we can say that f and g are inverses.